Hello friends and welcome to CEC online lectures. Friends, in today's unprecedented times, vaccine is a buzzword. Pharma companies across the globe are working in the direction of developing more effective and safer vaccines. Vaccines can be considered as one of the greatest invention or discoveries of the 19th century. These are also considered as one of the most useful medical creations. Since their discovery, lot of advancements have been made in the field of vaccines, specifically in their method of production or preparation. In early days, vaccines were prepared by using the target microorganism in the entire form, and that microorganism was either killed or inactivated or also weakened. But today vaccines are prepared by using a specific part of that microorganism, and this part can be either a specific protein, or it can be a toxoid or a toxin that is being produced by the microorganism. So by using that specific part, and that part should be responsible for stimulating the immunity, so nowadays vaccines are prepared. So this is just one example that how the advancements in the method of preparation of these vaccines have been made. So now we are using just a specific part of the microorganism which can stimulate the immune response in the body to prepare the vaccines. But one of the major problems with the vaccines is their route of administration. We know that majority of the vaccines, except one or two, say for example polio vaccines, which are administered through oral route, because we know that they are given in the form of drops. Majority of the vaccines are administered parenterally, or in simple words, if I say that vaccines are administered with help of injection. For almost all children, and not only children but also the adults, mere thought of injection makes them uncomfortable. So because injecting something or getting a needle pricked into your body part, that thought always will make a person uncomfortable. And that is why I said the route of administration, that is parenteral administration, is one of the major drawback of the vaccines, because parenteral administration or injection is not the most patient compliant route of administration. On the contrary, just imagine if you can eat your vaccine, or you just eat an apple or a banana and you get vaccinated. Or simple terms, just imagine that your vaccine is edible. So friends, this is what I am going to talk today, that is edible vaccines. Now in this lecture, I'll be discussing about etymology, that how the term vaccine was generated, a very brief history about the vaccines, that how the vaccines came into existence. Then I'll be discussing about the definition of the vaccines, that what are basically these vaccines, what are the different types of vaccines, whether those types are on the basis of their use or on the basis of their method of production or preparation. Then I'll be discussing what are the characters of an ideal vaccine, followed by what is an edible vaccine, why edible vaccines are required, how we can produce edible vaccines, what is their mechanism of action, what are the different plants that are used to prepare these edible vaccines, and in the end I'll be discussing about the limitations or the problems we face with edible vaccines. So coming on to the etymology or the brief history of vaccines. So friends, it all started by the end of the 18th century in 1796, when Edward Jenner performed his famous smallpox vaccine experimentation. So once he was done with his job in London, he shifted back to his native town to serve people of his village or town, because he was a doctor. During this tenure, he made certain observations, and he found that people of his village or his town or the surrounding villages who suffered from cowpox infection were resistant or immune towards the smallpox infection. So he gave the hypothesis that anybody who got infected from cowpox will be resistant or immune towards smallpox. In order to prove his hypothesis, what he did was he collected small amount of pus from the pustules of the cowpox and injected that pus into the arm of an 8-year-old boy, John Phipps. And according to his hypothesis, he found the results, and he found that the boy was immune or resistant towards smallpox infection. So he tried to publish his results, but the scientific community asked for more proof to his hypothesis. So he went back to his village and he increased the sample size by selecting more children, including his 11-month-old child. He again collected small amount of pus and injected that pus into the arm of those children, and as expected, he found that all these children who were injected with that pus were immune or resistant towards smallpox infection. So he again went back to publish his results, and now the scientific community did not have any reason to reject his hypothesis. So they published his results, and once those results were published, the scientific community was astonished by this hypothesis, his findings, and they start working in this direction. So Edward Jenner gave the term vaccine, and he derived the term vaccine from a Latin word vacca, which means cow, because he generated this from the pus that he collected from the pustules of the cowpox. So this is how the term vaccine was generated and how vaccines came into existence. So after the death of Edward Jenner, we know that Louis Pasteur was the person who continued his work, and he gave us some of the important vaccines which are still utilized, like vaccine for rabies and anthrax. So now coming on to the definition of vaccines, that what are basically vaccines. So these are nothing but these are the preparations or the agents that help in developing immunity against a particular infection or a disease. So they contain an agent that resembles a disease causing microorganism and is often made from weakened or killed form of the microbe or its specific protein or a toxin released by that microorganism. So what we do is we take that microorganism against whose infection we want to get ourselves immune. So we either kill that microorganism or we make that microorganism weak and we inject that into in our body, and our body immune system identify it as a foreign body and it start developing immunity against that particular microorganism. And by virtue of the memory of our immune system learns that in future, if the body is exposed to this kind of microorganism, we have to produce these type of immunities. So this is in layman's language that how our immune system works. Now coming on to the different types of vaccines. So as I told you that vaccines can be broadly categorized on the basis of their use or their method of production. On basis of their usage, vaccines can be prophylactic vaccines or therapeutic vaccine. And on the basis of the method of production, vaccines can be entire vaccine or subunit or conjugated vaccine. So obviously I will just briefly give you an overview about these different types of vaccines. So first coming on to the vaccines that can be categorized on the basis of their use. And in that we have prophylactic and therapeutic vaccines. So prophylactic vaccines are designed to build immunity in a patient. A prophylactic vaccine, or we can also call them as preventive vaccines, that is, these are given in order to develop immunity and to prevent a microorganism to cause infection to a body. So these can also be called as preventive vaccines, and these involve introducing antigens, and these antigens can be in the form of entire microorganism which is either weakened or killed, or it can be in the form of specific protein of that microorganism which can stimulate the immune response. So this involves introducing antigens into a person's body. The goal is that individual's immune system will create antibodies against these antigens and become immune to the associated illness. So when we inject a particular microorganism in our body, as I told you, that our immune system will develop antibodies against that microorganism, and in future our body will remain immune towards the infection that can be caused by that specific microorganism. So this technique works well, and such vaccines are very common. In fact, I will say most of the vaccines that we have been injected with were prophylactic vaccines. Most of the vaccines that we give to our children, they are nothing but these are the prophylactic vaccines, because we are protecting our children from certain infections before they are exposed to those particular infections. Now it's worth mentioning that these vaccines or the prophylactic vaccines are not guaranteed to be 100% effective. It is still possible for a person to become ill from a microorganism or a virus after becoming immune through vaccination, and even possible for the vaccination to have no effect on some people, because every body is a different system, I will say. So there are exceptions, though these exceptions are rare, but you will find that there are certain people who do not get any kind of immunity after they are being vaccinated, or still they get exposed to that particular infection, or they get particular infection for which they have already been vaccinated. But in general, majority of the healthy individuals can expect to get immunity boost once they are vaccinated. On the other hand, therapeutic vaccines are the vaccines that are meant to help the body to do a better job of fighting against an illness it already has. So for therapeutic vaccines, these are the vaccines which help our body or encourage our body immune system to fight against a particular disease which is already present inside the body. Now this is the major difference between prophylactic and the therapeutic vaccines. Prophylactic vaccines are given to protect our body from an infection to which our body has not been exposed till date. But the therapeutic vaccines are given to fight against the disease which is already present in our body, or our body is suffering from that particular disease. Say for example, cancer vaccines are there, HIV vaccines are there, Alzheimer's disease vaccines, though a lot of work is going on in this field, but still vaccines are there. Such kind of vaccines are the therapeutic vaccines, which encourage our body immune system to fight, to identify the dangerous cells, cancer cells or HIV cells, and encourage our immune system to fight against those cells. Obviously, how do we do it? We take certain antigens from the cancer cells only, or the virus from which we are being infected. So we take the antigens from the microorganism, or from the disease itself, and we inject them into the body. And we encourage our body to develop immunity against those cells, and not only to develop the immunity, but also to identify that our immunity has to fight against these kinds of cells. So this is about the therapeutic vaccines. Say for example, if I want to further elaborate on these therapeutic vaccines, therapeutic vaccine for cancer might introduce antigens created by tumors. So as I told you that we take antigens from the cancer cells only, from the tumors only, and this would effectively teach the body immune system to attack that antigen, as well as the similar kind of cancerous cells that produce it. A therapeutic vaccine for, say for example, HIV on the other hand, might introduce more HIV antigens into the body. Though the body is already suffering from HIV infection, but the HIV vaccine will again introduce the HIV antigens, and this will further help in strengthening our immune system or immune response of our body against HIV infection. So this is how these therapeutic vaccines work. Now, the area of the therapeutic vaccine is a very hot area for the pharmaceutical industry, and it holds a lot of promise for revolutionizing the treatment for certain disorders for which we don't have cure. Say, for example, cancer is one of them, Alzheimer's disease is another example, and so on and so forth. It's worth noting, however, that they aren't quite at the same level of establishment as the prophylactic vaccines, because prophylactic vaccines are being utilized since ages, since their discovery, and we have made so much advancements in the field of prophylactic vaccines. But in case of therapeutic vaccines, lot of work has to be done in order to get these vaccines, therapeutic vaccines, to a point where they consistently get great results for many people. So this is the major lacuna in the field of therapeutic vaccines, that lot of work, ample work has to be done in this area. Now, coming on to the categorization of vaccines on their method of production. And as I told you that on the basis of method of the production, the vaccines can be categorized into entire vaccine and the subunit and conjugate vaccines. Now, in entire vaccine, these can be prepared by using microorganism which is either live, or it is attenuated or weakened, or we can use killed or inactivated microorganism or the virus. Now, attenuated vaccines are prepared in different ways, and the most common method involves passing of the disease causing microorganism or the virus through a series of cell cultures, or they are allowed to divide in an animal cell. Chick embryo is normally used as an animal cell. So the virus is allowed to replicate in various steps, either in the cell cultures or in the animal cell, which is normally chick embryo. And with each step in the series, the virus gets potentiated in terms of its replicating capabilities inside the culture cell or in the chick embryo which is being used, but its replicating capability inside human cell are lost. Or in simple words, the virus will be active inside the culture cell or in the chick embryo, but it will not replicate inside the human cell. And once it is not able to replicate inside the human cell, it will not able to show its infectious response, or it will not be able to show its toxic effect inside the human cell. But yes, that virus will act as an antigen for the human immune system, and our immune system will recognize that attenuated virus as a foreign body, and it will start as an antigen, and it will start producing antibodies against that particular virus or the microorganism, and our body will get immunized against that particular virus. And or in other words, I will say that our body will get immunized against the infection that can be caused by that particular virus. So this is basically how the attenuated virus works. That is, it will unable to replicate in human cells, but that virus which is unable to replicate in the human cell can act as an antigen and stimulate our immune response to produce antibodies against that particular virus, and our body will get immunized against any future infection that can be caused by that particular virus. But one of the major concern is that these attenuated or the weakened virus can revert, or they can mutate to form that particular kind of virus which is capable of dividing inside the human cell. One. Second, they can further mutate into a more virulent strain. So once they mutate back or they revert to their capability to divide inside the human cell, so once such kind of virus is injected as a vaccine, so that virus, since it has mutated and has regained the capacity to multiply in the human cell, it will cause infection inside the human cell or the human body. Or if it gets converted into a more virulent strain, then a person may suffer from certain other more serious disease that can be originated from that virus or the microorganism. And because of this reason, oral polio vaccine has been discontinued in United States, because it has been found that because we know that oral polio vaccine is given through the oral route, it is not injected. So it has been found that this oral polio vaccine, because it contains the attenuated polio virus, it gets mutated and gets converted into a more virulent form, which causes a rare disease of paralytic polio. Though such kind of mutation is very rare, but one has to consider this rare instance also when you have to inject that vaccine, or when you have to administer that vaccine into humans, specifically in children. So that is why, because of this rare mutation of this oral polio virus into a more virulent strain that causes a paralytic polio, this oral polio virus vaccine has been discontinued in US, and now inactivated polio vaccine is being used, wherein the polio virus is first inactivated and then it is used as a vaccine. So this takes us to the second type of vaccine, that is inactivated or the killed vaccines. Now these are considered as a suitable alternative to the attenuated vaccines, and these types of vaccines are created by inactivating a pathogen, which can be a virus or a microorganism, and this inactivation is generally done by exposing that microorganism or the virus towards heat, or treating that microorganism with a chemical, which can be a formaldehyde or a formalin. Now with this exposure to heat or treatment with chemical basically destroys the pathogen's ability to replicate, but it keeps it intact so that our immune system identify it as an antigen and start producing antibodies against it. And they can't, since they are already inactivated, they can't revert in their dividing capability or their replicating capability, or they cannot be mutated into the virulent strain. And that is why, as I told you, that the inactivated polio vaccines are now being preferred in US over the oral polio vaccine. But one concern is that the vaccine that are prepared by killed or the inactivated pathogen tend to provide a shorter length of protection or immunity in comparison to the vaccines that are prepared by the weakened pathogens. And that is why the vaccines that are prepared by killed or inactivated pathogens, they require boosters. Booster doses are required to create a long-term immunity. Now we move on to the second type of the vaccines, that is the subunit and the conjugate vaccines. Now both these subunit and conjugate vaccines contain only piece of the pathogen they protect against. So they will be utilizing only a specific portion of that particular microorganism that can stimulate the immune system in our body, rather than injecting the entire microorganism, whether it is weakened or killed. So subunit vaccines use only part of a target pathogen to provoke a response from the immune system. And this can be done by isolating a specific protein from the pathogen and presenting that particular protein as an antigen in our body. The acellular pertussis vaccine or the influenza vaccine are the examples of subunit vaccine, wherein we extract out specific protein from those viruses and we use those protein molecules as the antigen to initiate the immune response. Another type of vaccine is the recombinant vaccine, and this is again a type of a subunit vaccine, which can be created via a genetic engineering. A gene coding for a vaccine protein is first inserted into another virus or into producer cell in culture. When the carrier virus reproduce inside the cell culture or another virus, or when the producer cell start metabolizing, the vaccine protein is also created. And our immune system will recognize the express protein and provide future protection against the target virus. And the most common example of recombinant virus that is being used today is the hepatitis B vaccine, which is currently used in United States as a recombinant vaccine. Now we move on to the conjugate vaccines. Now these vaccines are somewhat similar to the recombinant vaccines, and these are made by using a combination of two different components. First component is the piece from the coats of the bacteria that are chemically linked to the second portion, which is a carrier protein. So the two different components are, one is the piece of the bacteria from the bacterial coats or the specific protein, which is linked to the second part or the second component, which act as a carrier protein. And the combination of these two is used as a vaccine. So conjugate vaccines are used to create a more powerful combined immune response. Typically, the piece of the bacteria being presented would not generate a strong immune response on its own, whereas the carrier protein, the second component of the conjugate vaccine, will help in enhancing the immune response that is being produced inside our body. So one component will produce a light immune response, whereas the second component will help in enhancing the immune response that is being produced by the first component. So this is basically how these conjugated vaccines work. Now the specific piece of that bacteria that is being used can't cause illness, but when combined with a carrier protein, it can generate immunity against future infections. And the vaccines that are currently in use for children against pneumococcal bacteria infections, these are generally made by this conjugate method, or these are nothing but the examples of the conjugate vaccines. So friends, this was in brief about the different types of vaccines, how the vaccines came into existence, what are the different types, how they are prepared. So in the next lecture, I'll be discussing about the general characters of an ideal vaccines, what are the problems of the vaccines which we are using in today's world, what are edible vaccines, how we can prepare them. Thank you.